Okay, so what we're going to do today is start a new unit, and it's the function unit. So I would like you to put me on pause. Do the try this. The try this is to just graph these two functions. So you can use the graphing calculator on your Chromebook to do that. Make a table of values, plot the points. Okay, so when you plug this into the calculator, the first one, so you go into y equals, and you type in 3x minus 5, and we're going to make a table of values. So I'm going to use some some positive x values and some negative x values since it is just a line. So I'm going to use -1, -8, 0, -5, 1, -2, 2, 1, and 3, 4. Okay, so plot the points. All right, so I have -1, -8. Sorry, the graph is tiny. 0, -5. 1, -2. 2, 1. And 3, 4. And then connect those dots. Okay, and let's graph the second one. So you put that into y equals. It is a quadratic. So hopefully you guys realize that. Sorry, I just drew that line across the thing. So hopefully you realize it is a quadratic equation. So it is a parabola. So we're going to make a table of values. A parabola has a turning point. So when you look in your table of values, you do want to try to find where that turning point is. All right, so I'm going to graph -3, 0, -2, -6, -1, -10, 0, -12, 1, -12. See where these two repeat here? Sometimes you just have that one single value that's kind of like right in the middle, and then they start repeating on both sides. Then that's the value you should have in the middle. Okay, I'm sure you probably remember that from algebra 2. Then we have 3, -6, and 0. Oh, sorry, 4, 0. All right, so let's plot the points. So we have -3, 0. Sorry, I'm trying to do the best I can. I really definitely made these graphs too small. All right, so just try to follow along. So we have -2, -6. Then we have -1, -10. 0 is negative. So it's coming down here. Okay, and then we have -2, -10, 3, -6, and 4, 0. Okay, so draw your parabola. All right, and make sure you put your arrows at the end. Okay, so today we're going to start talking about functions. Relations and functions, actually. So let's start with the definition of what a relation is. A relation is just any set of ordered pair. So let's write that down. Any set of ordered pair. All right, so an example would be, now remember, ordered pair of points. 3, 4, 5, -1, 6, 0, any set. So even if you just have 1 point, that's a relation. Okay, so any set of ordered pair is a relation. All right, so now so basically every function, anything you can graph, anything you put on the graph is a relation. Okay, so now let's talk about what a function is. A function is when I don't know if you guys can hear my dogs playing in the background, but they're squeaking the toy. Sorry if you hear them. Every element in the domain. Now, the domain, hopefully you remember, are your x values. Okay, this is also called your input. Every element in the domain corresponds to 1 and only one element in the range. The range are your y values. That says range. Those are your y values. This is also called your output. Okay, your y values is called your output. So basically, if your x values don't repeat, it's a function. So if your x values do not repeat, it's a function. So remember, so your x values are also called your input. Okay? All right, so that will just do some examples. Okay, so let's take a look at the first example. So it says here we want to identify which relation. Now look, they're all relations, okay, are functions. Okay, so you look, these are ordered pair. This is just a bunch of different examples. So look at the values. I have 3, 5, 7, 0, negative 6, 5, 0, 10, negative 1, 3. You're looking to see if any of your x values repeat. So let's see, I have a 3, a 7, a negative 6, a 0, a negative 1. None of my x values repeat. So this is a relation that is also a function. So put R and F, relation and function at the same time. Look at B. I have 2, negative 8, 4, another negative 8. So look, I have 2 negative 8s. I'm not even going to go anymore. This is not a function because I have 2 of the same x values. This is just a relation, only a relation. Look at C. 3, negative 1, 2, 5, 6. None of my x values repeat, so this is a relation and a function. All right, let's take a look at D. So I have, look at the x's, 1, 2, 3, 4, 5. None of my x values repeat, so this is a relation and a function. Look at E. I have 2, 2, 2. All my x values are exactly the same. So this is not a function. You can't have any of the x values that are the same. Only a relation, E. F. I have 1, 2, 3, 4, 5. This is a relation and a function. Okay? All right, so let's turn the page and we'll try some more type of examples. Okay, so this is just, the first one is just representing the information using a table of values. So I have an X column and a Y column. This is your input. This is output. Okay, look at the X values. I really don't care about the output. I'm looking at the X values. I have 1, 2, 3, 4. Right, these are points. 1, 5, 2, 4, so on. This is a relation and a function. None of my x's are repeating. All right, look at B. I have 1, 6, 2, 7, 1, 3. I have my x's repeat. This is just a relation. It is not a function. Take a look at C. 1, 5, 2, 5, 3, 5, 4, 5. This is a relation and a function. Look at D. Look at all my x values. They're all the same. This is not a function. This is just a relation. All right, the next group, which is a mapping. A mapping is just another way to represent points. The first column is your input. This is your output. So look at the 1 and look where the arrow is pointing to 3. So this is like saying 1, 3. 2, 5. 3, 1. And then the last one, 4, 7. So notice none of my x values repeat. Right? I only have one arrow coming from each of my x values. This is a relation and a function. All right, let's look at B. So when you look at B, I have 1, 3 here. 3, 1, 4, 7. It looks like, right, none of my x values repeat. That is true. But however, look at this too. It's not being used. The definition of a function is every x value, every value of the input is used. So this is not a function. It's just a relation because the 2 is not used. All right, look at C. So I have 1, 3 here. I have 3, 1. I skipped the 2 on purpose. 4, 9. Now look at the 2. 2 goes to 5 and 7. It goes to 2 numbers. It's like saying 2, 5 and 2, 7. This is not a relation. This is not a function. It's just a relation. All right, look at D. 1, 5, 3, 1, 2, 5. It's okay if we repeat the y values. This is a relation and a function. All right, so now how do we do the graphs? So you might remember hearing vertical line test. When we talk about graphs or looking at graphs, use the vertical line test. I don't know why my stylus is not being cooperative today. So when we're dealing with graphs, use the vertical line test. Hey. Okay, so what is the vertical line test? The vertical line test is if you can draw a vertical line anywhere on the graph and it hits it only one time, then it's a function. It can only hit it once. No matter where you draw a vertical line, so let's write down, no matter where you draw a vertical, that says vertical line, if it hits the graph only once, it is a function. If it hits it 2 or more times, 2 or more hits, it is not a function. Okay, so let's take a look at the examples. All right, so look at number 1. It's a line. So no matter where I draw a vertical line, it's always going to hit this graph. Always will hit it just one time. This is a relation and a function. All right, take a look at B. I could draw a vertical line here. I could draw a vertical line here. It hits the graph more than once. This is just a relation. All right, C. No matter where I draw a vertical line, it's always going to hit the graph just one time. Once. So this is a relation and a function. Okay, so that's it, and we'll do lots of practice in class tomorrow. Everybody have a good night.